Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So as a little bit of a teaser for what's coming up this episode, I have been toying with the idea for I don't know how many months now of potentially upgrading my network attached storage solution, or my NAS. There's nothing wrong with my NAS. I just have kind of an urge to upgrade it, mainly for power efficiency reasons. The server I'm running is a Dell R510, and for only running 3 drives in it, and it's sucking down like 140 watts of power just sitting there doing nothing. It would be nice if it was a little lower, and when I do my archives of my NAS to back it up, it would be nice if it didn't spike as high as it does and still get the same performance. So it's something I've been looking into. Should I build something custom? Should I get something used? It's something that I've been thinking about, and something that I figured I'd talk about for this episode. But another thing that I like to do as far as topics for episodes is when you guys reach out and suggest topics for episodes. And quite honestly, those have been some of my favorite episodes that I've done, is when I'm answering questions that you all have. And if you actually have any questions or topics that you want talked about or answered on the show, you can email me at contact@darkassassinsinc.com. The link for that is in the show notes. So feel free to reach out if you have any questions, topics, or anything like that. So let's start off with this week's trivia question. So AI is all in the news, has been since pretty much December of last year, but Deep Blue was an artificial intelligence developed by IBM back in the 1990s. What was the purpose of Deep Blue? And that is your trivia question for the week. Now, speaking of AI, we live in a society. We live in a world where there is literally a bot, or an artificial intelligence, if you will, currently live streaming itself 24/7 playing Pokemon Emerald. And that probably doesn't sound all that interesting. It's like, okay, big whoop, a bot's playing a Pokemon video game, who cares? But it's the reason it's interesting is because it's trying to complete not only a living Pokedex, but also complete a Professor Oak challenge. All the while, all the Pokemon for the Professor Oak challenge and living dex have to be shiny. So if you're not super familiar with how the Pokemon in general, but specifically Gen 3 works, let's break down real quick how insane this proposition that this AI bot is trying to accomplish. So first off, let's go through what these mean. So first, what is a living Pokedex? So the point of a living Pokedex is, rather than you having, I believe in Gen 3, there's like 380 some total Pokemon. So instead of just having, completing the dex and having that number be, 380, whatever it is, you actually have each stage of each evolution. So you don't just have a Raichu that you evolved from a Pikachu. No, you have a Pikachu and a Raichu. You don't just have your Charizard that you evolved from your Charmander. No, you have a Charmander, a Charmeleon, and a Charizard. So you basically have every stage of every evolutionary line, and that's a living dex. And to build on top of that, the Professor Oak challenge is you have to acquire every Pokemon between where you are and the next gym. So every Pokemon and evolutionary line that's available to you before, the first gym, the second gym, the third gym, etc., you have to obtain. So they're basically taking the Professor Oak challenge, which is, I only need to catch, a Zubat and evolve it up to a Crobat. But they're taking that and adding on, I need to catch 3 Zubat, evolve 1 into a Crobat and 1 into a Golbat, and then keep 1 as a Zubat. So adding even more complexity to the challenge. But then they add on top of that the fact that every single one of them has to be shiny. And if you're not familiar with how shiny odds work, in Gen 3, you had a 1 in 8,192 chance that you would encounter a Pokemon and they would be shiny. And basically the whole point of a shiny Pokemon is the coloration is different. And some of the Pokemon, it's quite obvious, going from a blue Gyarados to a red Gyarados, or a red Charizard to a black Charizard. Or you have others that, if you're colorblind, you probably wouldn't even notice any difference at all, like me. So some of them are kind of interesting. Others basically just look more or less the same. But regardless, you have a 1 in 8,192 chance to encounter one. And that's assuming you have that many encounters with a single one of them. But if you've ever played Pokemon, you know that some Pokemon are quite rare to find in the wild and have a pretty low encounter rate. So you multiply their low encounter rate by this 1 in 8,192 chance, and you can kind of start to see how absolutely wild this challenge is. So, for example, some Pokemon have as low as a 1% encounter rate, meaning theoretically, to reach odds, you would have to encounter around 820,000 Pokemon before you found that one shiny. So, pretty insane. And also, for some additional context, this bot is currently averaging around 270 encounters per hour. So, yeah, it kind of takes a while. It's been, needless to say, it's been going for 236 days as of recording and has still yet to reach the first gym. It still has not even captured all of the shinies it needs to complete the Professor Oak's portion of the challenge. So it is kind of a little ways off. Now, if you're wondering how I know all this, as we'll get into a little bit later in the episode, I was doing quite a bit of coding this week, working on a project. And I wanted just some kind of like background noise, essentially, something in the background to kind of sort of pay attention to, but not really care about. And what better than an AI bot playing Pokemon round the clock, and basically nothing ever happens, but then occasionally, I might hear the sparkle sound of it being a shiny and be like, ooh, which I think I've only seen like maybe once or twice in like a week, so it's not all that common. I mean, as you would expect, 1 in 8,192, pretty low odds. So yeah, that's the society that we live in. And with that, let's get into this week's cybersecurity tip. So for this week's cybersecurity tip, this one is kind of going out to anyone who does a lot of traveling, specifically those who do a lot of air travel and are in airports. And one thing that's pretty common in airports is you'll see those like hubs of chargers so you can like charge your devices. And one of them that's very convenient is the USB charger. So you don't have to worry about getting a power brick out. You can just plug your USB cable into the USB outlet, plug it into your phone, and you're good to go. But you probably shouldn't be doing that. And the reason is there have been numerous occasions where attackers will set up these fake USB charging hub hotspot things and use them as ways to either collect data or deliver malware or the like. And the reason why they can do this is, first off, USB is kind of meant to carry data. So that's like if you try to sync your phone, to your laptop or to your desktop or whatever, that's how you do it, right? You connect it over USB and then you can transfer data to and from your device. So this is also allows you, if you're doing any kind of, for example, iOS development, you got to kind of plug your phone into your computer so you can transfer the app data onto your device. And if you wanted to transfer some malware on there, well, you could just plug your iPhone in and connect it to your device and, install your malware on there. So that's basically, what these malicious actors are doing. And this has actually been kind of going on for a while, as a matter of fact. Attackers have, so they set up these, public USB chargers to deliver malware for those that, plug their devices into them. And back in 2013, there was a malware called MacTans, I believe it's called. It was unveiled at a Black Hat security conference. And they were able to deploy malware through a USB outlet onto an iOS device all the way back in 2013. And obviously security has gotten better, but obviously attackers have gotten more skillful too in that time. So it's definitely something that you want to be cautious of. And personally, I wouldn't even bother plugging your phone directly into a USB outlet. I would just, take the slightly bit of extra effort to just plug it into your USB brick and plug that into a regular outlet, or just, wait to charge your device or whatever. That works too. Or if you don't have a USB brick to plug your phone into, you could plug your laptop into, a standard outlet and then plug your phone or whatever into your laptop via USB, and you can charge that way. So there's definitely ways that you can go about charging your device without using one of these public USB chargers, and if at all possible, I would avoid them because they can be malicious. They might not be, but it's, better to be safe than sorry. So that is your cybersecurity tip for the week. Now, this isn't exactly anything that I did, so I'm not counting it as a nerdy thing, but over the past couple of weeks, I've been documenting, I don't know if that's really documenting, but I've been talking about the updates that I made to Jeff Geerling's Top 500 benchmark and how I submitted a pull request and to try to get my changes merged into his main repository. And I didn't really think much of it the past, week and a half or so, since nothing had really happened. So I just kind of assumed it was just gonna, sit there in purgatory forever and never really get resolved or maybe get deleted or, whatever. But then just out of, for what the heck reasons, I decided to check yesterday evening, and I saw that Jeff Geerling added a planned label to the pull request. So I'm not sure how. I think as of when I saw it last night, that was like 3 days ago. So I guess we'll see. It seems like he's interested in adding it in, so I guess we'll see what happens. But yeah, I was pretty hyped to see that. So I guess we'll see where it goes, and I will keep you all updated. And with that, let's get into what nerdy stuff have I been up to this week. So, do you guys remember, I don't remember how many episodes ago it was, but we talked about how funny it is when you see a new big version of some software come out and how quickly the point release comes out after it. Like you get your big, 3 or like 5.0 release or something, and then like a week later you get a 5.1 that fixes a bunch of bugs that they introduced in 5.0. Yeah, I kind of fell into that category this week. I mentioned last week how I made some updates to my Server Connect script, and turns out in doing those updates, I introduced a bug, so I had to push a point release just over a week after I published the not necessarily major release, but, I think we went from like 3.2, I think is what it was, and then had to push a point release 3.2.1, like just over a week later. And the reason why I had to do this, so basically what happened was I re-architected how you actually connect to a server. So to accommodate instances where you had like a hyphen in your connection name, I didn't want to have to rewrite the same code to connect to connect to the server. So I was like, I'll just throw this in a function. And as part of that, I wanted to check to see if the connection actually worked. And the way I did that was I got a return code back from the OS system call. And I assumed that if I got a 0 back, that means that we connected and everything was fine. And under like 90% of the use cases, that works. Problem is, if your connection with the server you're connecting to gets abruptly terminated, like say you rebooted the system or you shut it down or you lost internet connection or something like that, it would assume that your connection failed because of the return code you received. So it was kind of funny because I was working on one of my servers and I did sudo reboot to reboot it, and I got this error message from my Server Connect program saying that it was unable to connect to the name of my connection. Make sure that it's in my list of connections and try again. Alternatively, I can try the username at the IP address. And I was like, wait a second, I did connect. Why am I getting this message? And I was like, oh no. And yeah, it turned out that SSH was returning a non-zero value because I rebooted the system and my connection was abruptly exited. So I had to rework that and get a patch put out and push that. So I failed I didn't go through as rigorous of testing as I probably should have, but it has now been fixed and patched, so it is what it is. Happens to the best of us. It's kind of funny, I make fun of how funny it is, when you see a new update come out. Okay, let's see how quickly the point release comes out, and here I am falling into the same exact category. But I mentioned earlier in the episode that the reason why I was watching that 24/7 live stream of the AI, and I mentioned that I was working on a fairly large project. No, it was not my video game, because that has again been put on the back burner for other projects that have come up, because I have too many of them. And quite honestly, I really do need my own personal dev team to just work on all these projects. But anyway, that's besides the point. If you recall back to, I don't know, maybe a year-ish ago, we covered a encryption algorithm called the elite encryption algorithm, and there was a Java application written by yours truly to implement it, and that was cool and all. But some of you out there are probably thinking of, first off, it's Java, so that's disgusting. And two, it has a GUI, which is also disgusting, because I am a hardcore GigaChad that only uses terminal-based applications, and anything written in Java or is a piece of garbage, and anything that's not, written in a language that compiles down to assembly is not worth my time. And if you are one of those people, you will be happy to hear that I am currently working on a implementation written in C, and I'm not exactly sure how much percent of the way done that I am, but the kind of the funny thing was actually implementing the encryption and decryption was pretty darn easy. I guess it kind of helps when, one, you invented the algorithm, and two, you already have source code of the algorithm from a different implementation that you can just translate into a new language. So that made it easy. Like, I'm pretty sure within it probably took maybe a couple hours to implement both the encryption and decryption part. And then the rest of my time this week has basically been just spent on making it pretty, I guess you could say, as much as you can make a terminal application pretty. And basically what I mean by that is make it more user-friendly, so you don't have to, recompile the entire program every time you want to encrypt or decrypt something else. So basically, removing any kind of hard-coded values, take in user input, and then, of course, whenever you're dealing with any kind of user input, as we've talked about on the podcast, you cannot trust user input. You must assume that all user input is malicious until you have proven otherwise. So putting in all kinds of checks in place to make sure that the input they're giving you is actually valid, and all that fun stuff. So basically been trying to work on that. And at this point, I think I pretty much have the key generation portion done, which that wasn't hard to implement, getting key generation. But what I wanted to also do, which the Java implementation doesn't have, is actually implement some kind of key management, so you can generate multiple key files and multiple sets of keys and use which one you want. And in addition to that, have the ability to encrypt your keys so they're not just sitting there in plain text. So I've been working on that. I thought I was done with it, and then there was something else little that I wanted to work on related to it, and then I thought I was done with it, and then there was something else I wanted to work on related to it, and then I thought I was done with it, and then I noticed there was a bug, and I had to patch the bug. So it's taken a little bit of time to get that working, but I think at this point, I finally got that sorted. So now it comes the, I guess, easier part. Now that all that key work is done, it's at this point it's pretty much, do you want to encrypt or decrypt? Okay, cool. What's the file you want to encrypt or decrypt, and do the encryption and decryption. All the functions for how to do that are already written. So it should be, I would think, fairly quick to implement the rest. I have thought about also having the ability to encrypt and decrypt directories, since the Java version has that capability. And I don't think it should be too difficult, but then again, I guess we'll see what happens when I get there. And then, of course, another thing that I want to do is, if I do actually get the directories portion implemented, then you already know that I got to do some kind of multi-threading capability in this, because it's me, and we got to make this, performance-oriented, because the Java version, I didn't even bother doing any kind of threading in there. So if you're encrypting an entire directory or decrypting it, have fun with that. Uh, especially if you have a lot of big files, it's gonna take a while. So potentially try to add some support for multi-threading. I think would be good. Obviously, if you're only gonna be encrypting or decrypting one file, you really can't multi-thread that. Because the nature of how the algorithm works, you can't really chop up the file and encrypt it efficiently without heavily modifying the algorithm. But what you can do is if you have a bunch of files that you want to encrypt, it's pretty trivial to multi-thread that process because each file is its own encryption process, right? So you can imagine what you can do is if you have, say, a directory of, say, 80 files, you can take how many processes or how many threads you want to run it on, divide those 80 files up evenly amongst the threads you want to run, and then just have each thread churn through encrypting or decrypting all of those files and significantly speed up the process. So it is something I'm definitely going to be looking into at some point, but obviously I need to make sure that I can get user input to encrypt and decrypt files and even folders implemented before I even start thinking about multi-threading, because as I mentioned, if you're only encrypting or decrypting one file, multi-threading is honestly worse because you have all the overhead of spinning up threads that you're never going to use. So, and as we've talked about on the podcast before when talking about multi-threading, you have to actually have a use case for it, because depending on how computationally intensive or how much I/O is involved, you could potentially see significant slowdowns. I mean, realistically, you're probably, as the user, probably not going to notice, but if you actually put a timer on your code's execution, you'll see a slowdown using threads versus just doing everything single-threaded, because the process of actually creating threads and, assigning them functions and running them and joining them back together takes a little bit of overhead. So if you don't really have that large of a computationally intensive project or process, like encrypting a small file, spinning up a thread to encrypt a single small file is probably not going to be worth it. Similarly, if you had like 5 small files, it's probably, again, not worth it to spin up, spin up a couple threads to divide those files across the threads and then encrypt them. Probably not worth it. Now, if you're dealing with very large files and you have a lot of them, then, spinning up some threads will, make the process go faster. But again, it kind of comes down to how big your files are and how many of them there are, in regards to if threading would actually be useful. But I still want to, incorporate that feature into it. And that's the nerdy stuff I did. So now let's get into the main topic that I wanted to touch on, that I alluded to in the very beginning of the podcast, which is this idea of, should you build your own server or should you buy one? Now, we've talked on numerous occasions on the podcast about sourcing, computers and servers for your Homelab, and, the kind of ways to go about doing it, what to look for, that kind of stuff. But I wanted to take a little bit of a different approach this time, since rather than, looking for specific specs and features, this time I kind of want to look more into, should you go the custom route and build a server yourself, or should you just buy a used one that's already, pre-built and ready to go? And I've actually done both. Aside from my first, server, if you will, that I got, which was a Dell Optiplex 7010, I think it was. That was like the first computer I used as a server, which in reality it's just a desktop that I converted into a server. But my, quote unquote real server, if you will, that was rack mountable, I built myself. in all reality, it wasn't the best server. It was kind of lacking in RAM. PCI expansion had basically none. CPU power-wise, it was okay. Storage-wise, not great. So it definitely wasn't the best server, I'll say that. And for the amount of money that I had to spend on parts to build it, probably wasn't worth it, and probably would have been better off, buying a used enterprise one. But regardless, it was still cool, to go through that whole process of building a server from the ground up, seeing, really getting an appreciation for all the components that go into building a server. Now, one thing that I would recommend to anyone that's interested in computers is at some point you should build your own at some point, whether it's a desktop or a server, to just get an appreciation for all the various components that have to come together in order to make a computer function. Because it's so easy, to go out to Best Buy or Walmart or some other retailer and pick up a computer, buy one off Amazon, and you turn it on and it works fine. But actually having to go through the process of sourcing all the parts for it, putting them all together correctly, and testing to make sure everything works, kind of gives you a better appreciation for, how computers work. And also, if you ever run into an issue with your computer, since you put it together, you kind of know, theoretically anyway, kind of the ins and outs of it and how things work together. So it theoretically would be easier to work on than, say, a pre-built or something. And the other benefits, I guess, to building your own, like I kind of we're alluding to here, is you have a lot more customization. You can decide which kind of RAM do I want, what motherboard do I want, what CPU do I want. You're not stuck with what someone else before you decided should go into this computer. You can, make all of that all those decisions yourself and really make it your own. So in that sense, it is very nice. Now, I guess one of the slight cons, depending on it really also depends on what you're building for. If you're just building a server to be a server in the sense that, in the most literal sense of the word, it is a computer that serves a function, like it is a computer that hosts your VMs, or it is a computer that hosts your development environment, or it is a computer that hosts your NAS solution, then in that sense, it really doesn't matter what case or anything like that, and you could, build it in an ordinary desktop case and be happy with it. But if you're a crazy person like me and you have a rack at your house to rack mount server equipment like they do in data centers, and you want a rack mount solution, then it's a lot harder to justify, in my opinion. Because if you've done any research into building your own rack-mounted server or computer in general, it's not cheap. Like, the cases alone, generally speaking, you can buy an enterprise server for the same amount of money as your case costs. And that's before you even source the motherboard, the CPU, the power supply, the RAM, the storage. And quite honestly, from the server cases that I've seen that are rack mountable, like the old enterprise ones, in my opinion, just look better and function better. So if you're trying to create a server to emulate an enterprise grade server, you're going to be hard pressed to get all the features that an enterprise server has with the performance that an enterprise server has for anywhere near the same amount of money that a used enterprise server would have. Now, if you want to compare directly against a brand new enterprise server, then it's probably pretty darn easy to beat, because I don't know if you've ever tried to configure a rack-mounted server on like Dell's website, but my goodness, I've seen houses go for cheaper than some of the servers that you can configure on Dell's website. My goodness. But if you're going like the used route, trying to get, something like an R620 or an R730 or something like that, an older enterprise system, you're going to be hard-pressed to build a comparable system with similar amounts of power and features. Because if you want any kind of lights-out management, you're going to have to get a special motherboard for that, and that's going to cost you extra. Not to mention the fact that if you want as much like PCI expansion as enterprise servers have, that's going to be really hard to find any consumer grade motherboard that has that kind of support. If you want like SAS capability, which is, if you're not familiar, there's basically, well, I guess now with NVMe, it's basically a kind of connector that you can connect your storage to. Typically, SAS connectors were more enterprise grade, and then there's SATA, which is basically the same thing as SAS, but essentially SAS only works with SAS, where SATA can work with both SATA and SAS. So generally, if you have something that has SAS capability like enterprise servers, you can basically throw whatever drives you want. And then of course there's NVMe, which is kind of the newer version with the slim, super small SSD type drives, that kind of a thing. Anyway, so if you want something with like SAS capabilities, if you're going the build it your own route, you are pretty much going to have to get an external or a PCI card to handle that, because most consumer motherboards are pretty much SATA only if they have it. Plus, the other fact too is the number of SATA ports that you can have on a consumer motherboard are generally limited. Now, depending on what you're using your server for, that may or may not be an issue for you, but it's definitely something to keep in mind. Now, on the plus side to building your own server, you're almost, not necessarily guaranteed, but you're almost guaranteed to use significantly less power. Because one thing enterprise servers are not good for is power consumption. They really do like to suck down the juice, even if they're not doing anything. See my R6 or my R510 that is sucking down, 140 watts just existing. Now, with that said, you can totally, build a consumer or a non-enterprise system, that you built yourself that draws a ton of power too. But if you're building it yourself, you can generally, because you're not necessarily using enterprise hardware, you're kind of using, consumer motherboards, maybe consumer CPUs even. Your power draw is generally going to be significantly less than, say, an enterprise solution. And on the same topic, if you're building it yourself, it's probably also going to be a lot quieter than if you got an enterprise server. Now, in fairness, some of the newer enterprise servers can be fairly quiet at idle, like obviously still audible, but can be fairly quiet, and you can even make them even quieter. There's plenty of GitHub repos out there of people, writing scripts to basically control the fans through the IPMI interface or the remote management interface on these enterprise servers. So you can basically make your own custom fan curves and whatnot. So you can make the enterprise servers fairly quiet, but they also have the capability to be very, very loud. But I guess that also kind of comes with the territory of a rack mount system, because if you're part of the issue with building a custom rack mount solution is space limitations. Now, you can go massive and, get like a big chunky 4U case, but then that's 4U of rack space that you're taking up for just one computer. On the other side, if you created a smaller, got a smaller case, like even a 2U, or somehow you managed to cram a whole computer into a 1U case, which, my goodness, there's a lot less space in there, meaning there's a lot less air in there, meaning your heatsink can't be as big, so you need to push more air over your heatsink to cool your CPU. And if you have to push more air, that means you have to run your fans higher, which means louder and more power draw. So there are definitely pros and cons to each solution of how you want to go about, size-wise for your server chassis. But regardless, it's quite the process, to build your own server. Now, I remember when I built mine, I didn't necessarily, mine was kind of not great because the cooler that I actually put on there was basically just as loud as an enterprise grade server. And as a matter of fact, at one point when I had my custom built rack mount server in my R620, which, keep in mind, is a 1U system, so very, very tiny, it was quieter than the custom built one I made, which was a 2U system. So, yeah. Now, I definitely could have built it better. I could have used a different cooler. I mean, if I would go back, I probably would have completely redid the build I did. But I never had really built. That was, quite honestly, the first computer I had ever built. It also happened to be a server. So I was basically just following a guide that Craft Computing put together. Basically following it to the letter almost. But if I had to go back, I would definitely do things differently. But getting back to the predicament I'm in now with my trying to potentially upgrade my NAS solution is I haven't been able to find anything convincingly, that fulfills all the requirements, I guess, that I put for myself. And price, obviously, one thing. Now, you could argue price is subjective. To some people, $1,000 server is nothing. To other people, a $200 server is breaking the bank. It really depends on where you are. But for me, I haven't really found anything that's a good enough deal that makes me go like, oh man, I gotta get that. And because I haven't found anything, I've toyed with the idea of, should I just get build my own NAS. And the problem with that I've kept running into is when you break it all down, I can make a system that's probably a lot more power efficient than any enterprise server, but for the performance that I'd be getting, and it's hard to justify, because the price, having to source everything, one, trying to find a rack mount case that, one, I like, and two, is as expandable as an enterprise case is kind of hard to do without basically being the same price as just buying an enterprise system. Because it'd be cool to have, hot swappable drive bays on the front like I have now. But trying to find a consumer, or not necessarily a consumer, but a case, a rack mounted case that has that's not absurdly expensive, kind of hard to find. And most of the ones that I've found that are similar to that are either a 4U or 3U case, which ideally I don't want because I already don't have any more rack space as it is. So that's one challenge. And then the other challenge that I've also ran into is motherboard selection, because ideally I want to have a decent amount of expansion slots, because probably would need some kind of host bus adapter or HBA card, to connect drives to, because some of the drives or one of the drives, I guess, and potentially more if I have other drive failures, or if I wanted to expand the amount of storage I have, would be using SAS. And like I mentioned, most consumer motherboards operate with SATA, so I'd have to have a expansion card for that. And then I would want an expansion card for my 10 gig connection, so I'd need another slot for that. So trying to find enough PCI slots. And then if I wanted to go with a consumer grade CPU, finding a CPU that has enough PCIe lanes. So it's pretty much been something that I there's so much that goes into it that there's been nothing that's really stuck out as like, oh my gosh, this is it. So I've been just kind of ignoring it. Because at the end of the day, if it ain't broke, don't fix it. My current NAS solution works, so why bother? So that's kind of the predicament that I'm in. Now, when it comes to going back to should you build your own versus should you buy a pre-built used enterprise solution, some other potential, kind of as we've been talking about, if you want to build your own custom solution, while you can, make it more power efficient, you can, get all the components you want, there's a lot of research and, investigative work and time and effort that goes into, making sure you pick all the parts you want, your parts are compatible with each other, and all this stuff. Whereas if you get a used enterprise system off like eBay or something, all that's done for you. Pretty much all you have to do is plug it in and turn it on. Another thing is, depending on which consumer route you go, you may or may not be limiting yourself as far as future expandability or future upgrades. As I mentioned, some of the consumer grade, like motherboards, for example, are kind of limited on their number of PCI Express expansion slots for, the kinds of cards that you can put in there. So if you want like a network card and say maybe a GPU or like a host bus adapter to connect more drives, or whatever the case may be, you're going to be potentially limited on that front. So the ability to scale out. Plus, if you ever want to maybe upgrade your CPU down the line, probably not going to happen. Now, granted, depending on the enterprise system you get, you might not have too much there either. But one benefit the enterprise solutions have is, say if you get like an R620, for example, when I first bought mine, it came with an E5 2670. It came with two of them. And the cool thing about the R620 is it's on the LGA 2011 platform, which basically means that it can support the same CPU generation that I currently had, but it also had support for the CPU generation that was newer than the one that came installed with my machine. So if I wanted to, and I did, I was able to upgrade the CPU in there and get even more performance out of it. The other thing that you'll also have to keep in mind versus going custom versus enterprise system is you're going to be going back to the expansion component is RAM. Now, depends on your use case. The nice thing about, say, an enterprise grade solution is they have so many RAM slots and they can have so much RAM. Like, for example, my R620 can have up to I think 1.5 terabytes worth of RAM installed. I think it has like 24 RAM slots. Now, obviously, I'm not using nearly all of those. I'm not even using close to all of them, and I'm not anywhere close to 1.5 terabytes of RAM. But the nice thing is, if I ever need more RAM, it's really easy to install more RAM. Whereas if you're getting like a consumer grade, motherboard, you probably only have 4 RAM slots. So if you want to upgrade your RAM, you're probably going to have to get another new set of RAM sticks rather than just adding new ones in. The other thing too is if you're using like a consumer grade CPU, you're probably going to be limited as to what the maximum amount of RAM you can have in your system is. So that's another potential thing you have to keep in mind. And another thing too, when thinking about maybe making a custom one, is reliability. Now, you might be the best PC builder in the world, but at the same time, the enterprise systems have been basically running 24/7, 365 for however many years since they were initially deployed. And that because that's what they're designed to do. So they're basically proven to work, and, they're good in that sense. Now, I know I've been kind of hating on the custom-built solution quite a bit here, but in all reality, I do think it is a really good. It's still a good way to go about it, and honestly, if you're not concerned about rack mountability like I am, it's even less of a concern. And I mean, heck, build your own PC if you want for cheap. But then you could also make the argument you could buy, an older desktop system like an Optiplex or something. But at that point, if you're thinking of like an old desktop versus building like a newer desktop to act as a server, in that sense, you might almost be better going like the custom route and building it yourself, because again, you have more customization on, the CPU, the motherboard, and that kind of a thing. And if you're simply just concerned about having a single computer that has cores and some RAM and can do stuff, and is power efficient too, it might be more beneficial to go the custom route in that sense. But again, you also have the overhead of having to source all the parts, do the research into what's compatible with what, and kind of speccing out your system, whereas, just buying something already made, whether that's new or used, is potentially a lot easier. But then the other thing too is if you're trying to if you're thinking of using this as a server, one thing that you also have to take into account, I guess, too, is what kind of access do you want to the server? Do you want any kind of lights out management access to it? Do you want the ability to be able to remotely turn it on and off? Do you want the ability to remotely see what's on the console without actually having to plug in a keyboard and monitor to it? In that sense, you can buy motherboards that have, some kind of baseboard management controller that will allow you to connect through like IPMI or some other, lights out management solution to get that kind of information. But that's pretty much baked in to every enterprise solution. So, and mind you, if you're buying a motherboard that has some kind of, baseboard management controller that will give you that remote management capabilities, that's obviously going to come at a premium. So adding even more cost to your custom build. But again, the cool thing about the custom build is you can pick your own chassis, you can pick your own components, and really get to understand the system and have a fantastic learning experience along the way. So as someone that has done both, bought used enterprise systems and built my own system, I am torn on which one is better. Now, I like the fact of having enterprise grade stuff, mainly for kind of the cool factor, and, potential future job experience, maybe, saying that you worked on, enterprise systems that potentially could be marketable. But at the same time, building everything and putting all the components together and turning that server on for the first time is also pretty rewarding as well. So I don't think you can really go wrong either way. It's mainly of, are you trying to get the most bang for your buck? Or are you trying to build a server that you're going to really enjoy using and love to have? Because potentially on what your use case is and what you want to get out of it, and like your price and price range and all that kind of a thing, could definitely determine which route you go with. But regardless, servers are pretty cool, whether you're just using an old desktop or you're a crazy person like me and have a rack full of them like a data center. Regardless, they are very cool to have and fun to play with. And regardless of what solution you go with, hopefully this kind of breakdown of the pros and cons of going enterprise versus custom built helped you out. Now, speaking of enterprise grade servers, I guess kind of tangentially related, relates back to our trivia question with IBM. Now, IBM actually does have some enterprise-grade servers around too, but specifically in relation to our trivia question, that's more, they built a supercomputer to house an artificial intelligence. So, this week's trivia question is, Deep Blue was an artificial intelligence developed by IBM back in the 1990s. What was its purpose? And if you said to play chess, you are correct. And another fun fact, it actually beat the reigning world chess champion back in 1997. So another cool tidbit for you there. And if you enjoyed this week's episode, I ask that you leave it a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. And be sure to share with a friend or family member that's maybe thinking about what kind of hardware they should source for their Homelab, whether they should get a custom-built solution or buy an old enterprise-grade system. And if you have any questions, like I mentioned in the beginning of the episode, you can shoot me an email at contact@darkassassinsinc.com. Link for that down in the show notes below as always. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.